Okay, dear students, so today we will see from the question number 6 and onwards. In our previous lecture, we solved the Cambridge International ACE in A-level physics paper of 1 and whose code is 9702 or 12, and it was conducted in February-March 2023. So now today we will see that what the question number 6 says. So the graph shows the variation with time of the displacement s of an object. So this is the graph, and it shows the variation of the displacement with time of an object. Now, which graph represents the variation with time t of the acceleration of the object? So this is the graph with of the displacement with the time, while the below the graphs are the acceleration with the time. Now we have to tell them, according to these information from this graph, we have to tell them that which graph tells us about the acceleration a of the object with the time. Now, so from this graph we can see that this is a straight line and it gives a concept of constant velocity. So it is a constant velocity. Now we know that acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. So when there is a constant, when the velocity is a constant, so this is a derivative. You can say that when there is a constant rate or there is a constant velocity, so we will take that, for example, velocity is constant, any constant. You can take 5, 10, 7. Now we'll say that the rate of change of that constant will be 0, or you can say that the derivative of any constant is 0. It means that acceleration of a constant velocity is 0. Okay, so in these graphs we'll see that which graph acceleration of body is 0. So in this graph you can see that the acceleration is not 0, it is decelerating. So this is not a correct option. So in this graph it is not it is not a 0 acceleration, so this is also not a correct option. While in this graph you can also see that acceleration is there is an acceleration up to this point, so this is not a correct option. So we left with an option D, and it tells us that from a point, from this point to that point, this is a constant velocity. So this represents the 0 acceleration. So we will say that the correct option is option D. Okay. Which expression defines force? So we have to tell them which expression defines force in the below. Now we know that force is mass times acceleration. Now if there is any equation, if there is any statement in the below, then we can say that also it says mass times change in speed, mass times change in speed over time, change of momentum. So it means that we have to convert the force into we have to write the force in terms of momentum, so we can write it. Now we know that acceleration is the rate of change when velocity. Now we also know that now the force will become, we also know that mass times velocity is linear momentum, so it will become change in linear momentum over time taken. Now if there is any option change in momentum over time taken, then it will be the correct option. So this is not one, this is not a correct option, this is not a correct option. So this is a change of momentum times time taken, but it is not. So change of momentum, so this is the correct option, change of momentum over time taken. Now moving to our next question. A ship of mass 8.4 × 10⁻⁷ kg is approaching a harbor with speed of 16.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? Now, a ship is approaching towards a harbor with a speed of 14.54 meter per second, and the ship mass is that much. Now we have to find that if there is a force acting 920,000 Newton, then how long will the ship take to stop? So for this for the time, we'll say that we will use the first equation of motion, and it is final velocity equals to initial velocity plus acceleration times t. time taken. So acceleration multiplied by time taken. So for this we have what we have to find the time taken, and while we do not have any value of acceleration, while we have the velocity. Okay, now for this we first of all we have to find the acceleration from the equation of force F equals to ma. So we'll say that yes, we know that force is equal to mass times acceleration. Now from this equation we'll get the value of acceleration, and that is F for m. Now if is 920,000, so if we convert this 920, if you write the 920,000 into a significant figures, then we will say that 9.2, a scientific notation form, 9.2 cross 10 to the power 5 divided by what is the mass of the ship? Mass of the ship is 8.4 cross 10 to the power 7. Okay, now the acceleration will become, okay, let's calculate it. So 9.2 divided by 8.4, it will be equal to 1.095. So 1.095 cross 10 is the power. So we will shift this 10 to the power 7 to the numerator, and it will becomes negative power. So 5 minus 7. Now it will be equal to 1.095 cross 10 to the power minus 2 meter per second square. So this will be the acceleration. Now what will we do? We'll simply put the value of acceleration and the velocity in this equation, and this first equation of motion, and then we will get the value for the time. Okay, so as this is a stopping force, so it means that there is a deceleration in the ship, so it will be a negative acceleration, or you can say it will be a deceleration. Okay, now the final velocity is 0. So the final velocity is 0, while the initial velocity is 16.4 meter per second square plus negative of 1.09. Okay, okay, negative of 1.095 cross 10 to the power minus 2 meter per second square. This was the acceleration, and multiply by time. So we will shift this 16.4 to the left side. It will become minus 16.4 equals to minus 1.095 cross 10 to the power minus 2 multiply by time. So from this equation we will get the t that, so we will divide both sides by 1.095 cross 10 to the power minus 2. So we'll get minus 16.4 divided by minus 1.095 cross 10 to the power minus 2. Okay, now time t will be equal to, again the negative signs will cancel each other, and we will now calculate the t. So 16.4 divided by 1.095, it will be equal to 14.977. So it will be equal to 14.977 seconds. Now if there is in any option, then you can take 14.977 cross 10 to the power, so this minus 2 will be shifted to the numerator, and it will become plus 2. Now we'll get that if we remove the power, so we'll get that 14.97 seconds. So if there is any option 1497 second, then it will be correct. So there is a 15 second, 150 second, 25 minutes, 250 minutes. So it means that we have to convert this second into minutes. So simply we will divide this second in by 60. We'll convert it. So divide 1497 by 60. Now it will be equal to 24.95. It will be equal to, so it means that this is equal to 24.97 second. You can write it minutes. You can write 25 minutes. Okay. Now time becomes 25 minutes. So let's see here that the C option is correct one. Now moving to the next question, that is the velocity time graphs for four different objects are shown. So there are four different objects and the velocity time graphs of these objects are given. Which graph represents an object falling from rest through a long distance in the Earth's atmosphere? So if you look at this graph, the option A, then you will see that this is a graph of a constant, you can say of a constant velocity or increasing velocity with a constant rate. So this is a constant velocity or increasing velocity with a constant rate. Again, there is a constant velocity. There is a constant velocity while when an object is falling, for example, this is a point, an object is falling, this is the Earth's atmosphere, this is the Earth's atmosphere. Okay, now if an object is falling, for example, it is falling from this point, and so the acceleration at that time will be 9.8 meter per second square. So it means that this acceleration means that after every second the velocity of the object will get increased 9.8 meter per second. The velocity after so this means that the velocity of the body will increase with a constant rate of 9.8 meter per second. Got my point? So this is basically a hidden point in it. Now a time will reach when a body is falling freely, a time will reach that this is a body, a time will reach that the reverse force, you can say that the drag force of the atmosphere of the particles of the air will become equal to, so a drag force is also applied by the particles of air on this object. So a time will come that the weight of this object will be equal to the drag force, the drag. After that the body will move with the constant velocity, and that velocity is known as terminal velocity. That velocity is known as terminal velocity. So for the first time, with slowly and gradually, with the passage of time, the velocity of the body will increasing, but a time will come that the weight of the object and drag force will be equal to one another, and after that time the body will move with a constant velocity, and that velocity will be known as a terminal velocity. So this is not, so with the passage of time the velocity with the velocity of the body increasing, so it is increasing, it is not moving with a terminal velocity. So this is not the correct option. So this option is a correct one. Why? Because till here the velocity of the body was increasing, but after this the body starts motion in constant velocity, and that constant velocity is known as terminal velocity. So option D is correct one. Now question number 10 is statement about collision is correct. So we have collision, we have interaction between the objects. So there are different collision, like elastic collision, like inelastic collision, like perfectly elastic collision. So which statement is correct about collision? So kinetic energy is conserved in all collision. No. Why? Because kinetic energy is only conserved in elastic collision, in inelastic collision. Okay. Kinetic energy is only conserved in an elastic collision, while momentum is conserved in all collision. Okay, so momentum is only conserved in, the second option is momentum is only conserved in perfectly elastic collision. No. So there is a condition that momentum is only conserved in perfectly elastic, while momentum will be conserved in all collision. So this is not a correct option. This is not a correct option. Option A and option B, these are not the correct one. So the relative speed of approach is equal to the relative speed of separation for perfectly elastic collision. Yes, this option is correct. Why? Because after the perfectly elastic collision, the relative speed of approach is equal to the relative speed of separation of the two bodies after the perfectly elastic collision. So this is a correct option. When two objects of different masses collide, they exert forces of different magnitudes on each other. No, this is not a correct option. This is again wrong. Now moving to our next question, that is, a satellite uses two thrusters to adjust its motion in space. So this is a satellite. It uses two thrusters. The thruster 1 40 Newton, thruster 2, 40 Newton force. Each thruster exerts a force of 40 Newton on the satellite, so they are exerting 40 Newton force on the satellite. The line of action of each force is a perpendicular distance of 2.3 meter from the center of gravity of the satellite. So there is a perpendicular distance from the center of gravity of the satellite, so this is that distance, and it is 2.3 meter. 2.3 meter. Now these two parallel forces act in opposite direction. Now these two parallel forces, so the 40 Newton, which will these are applied by the thrusters. So these are in opposite direction. So this is in downward direction, and this is in upward direction. Now let's suppose that if in upward direction is in positive, if we take the positive force, in the negative direction we take that it is the downward direction we take it is a negative. Okay. Now, what are the magnitudes of the torque and the resultant force acting on the satellite due to the two thrust forces? So we have to find the magnitude of torque and the resultant force. So now, before going in the detail, let's decide that if one force is downward and the other force is in upward direction, and both forces have equal magnitude, then there will be no resultant force. They will cancel the effect of each other. So it means that the resultant force will be 0 Newton. So it will be 0 Newton. Okay. While the torque, so if this force provides the torque, if this force gives the torque in this direction, and this force gives the torque in this direction, so both the torques will get together to rotate this satellite. Okay. So we will add these two torques from the due to the two thruster. So the torque produced by this thruster will be equal to torque is equal to R cross F, and you can write RF sine of theta. So if there is 90 degree, you can say that there is a perpendicular distance, there is a 90 degree invent, and sine 90 equals to 1, so we get only RF. So torque equals to 2.3 multiplied by 40, and it becomes equal to 92 Newton meter. So this is a torque due to one thruster. Now due to two thrusters, the torque will be added together. And we get 184 Newton meter. You can write it as 180 Newton meter. So the resultant force will be 0 Newton. So this is a 0 Newton, but the torque is 92 Newton meter. Okay. While here it is 80 Newton, while torque is again 92. So here it is 180 Newton meter, while resultant force is 0 Newton. So our correct option is C option. Okay. Moving to our next question, that is, the diagram shows two ways of hanging the same picture. So yes, this point must be noted that these are the same pictures. It means that they have same weight, or you can say that they have same mass. Now, in both cases, a string is attached to the same points on the picture. So this is a string, these are strings. Okay. And loop symmetrically over a nail. So there is a symmetry among these string or a nail in a wall. Okay. The forces shown are those that act on the nail. So these are the forces T1 and T2. These are acting on the nail. In diagram, the string loop is shorter than in diagram 2. So this is the string loop is shorter than, so this loop is shorter than in the diagram 2. Okay. Now, which information about the magnitude of the forces is correct? So among these statement, or among these information, which one is the correct option? Now, I will say again that before going in detail, I will give you a concept that this was the same picture, so it has same mass, it has same weight, then this is a resistive force, or you can say these resistive forces will be equal to one another. So R1 will be equal to R2. Okay. Now we have decreased our option. So yes, option A can be correct one, option B can be correct one, while option C and D, this cannot be correct. Why? Because there is no equality in the R1 and R2. Okay. Now let's see here that when a T1 will be greater or T2 will be greater. Okay, now let's resolve into vertical and horizontal components. So if we resolve this, if we make it a complete triangle, then we will resolve this. So this is a horizontal component of this T1 and this is the vertical component of the T1, and this is same, the horizontal component of this T1, while this is the vertical component of this T1. Okay, I mean horizontal with the x-axis, not with the y-axis. Okay, now this is an angle theta 1, you can say, and this is angle theta 1. These two angles are equal. Now we will also resolve this into horizontal and vertical components. So this is again theta 2 and this is theta 2. Now theta 2, this angle is equal to this angle, while because there is a right angle triangle, there is an equilateral triangle, and this is also again a same, these angles are also equal to one another. So but theta 1 is greater than theta 2. Now this point should be noted that theta 1 is greater than theta 2. Now we want to find T1. So for T1, if I want to write, if I want to find for T1, so this is R1, this is the resistive force R1. So and also this is the vertical component is also equal to R1. Okay, now if I apply the cos angle, the cos formula to this triangle, then it will be equal to, then cos theta 1 will be equal to, so it is base over hypotenuse, so base is R1 over T1. Now I want to find the T1. T1 will be equal to R1 over cos theta 1. Okay, now this point should be noted that T1 equals to R1 over cos theta 1. Okay, similarly for T2 we get that T2 will be equal to R2 divided by cos theta 2. Now you know that R1 equals to R2. It means that the numerator of the two equations are equal. For the T1 and T2 are equal. Now the only dependent factor will be cos theta 1 and cos theta 2. So if theta 1 is greater, if theta is greater, it means that it is going towards 90. If it is going towards 90, the cos theta will be decreasing. So if cos theta is decreasing, if we divide a greater number by smaller number, we will get a greater number. So let's suppose that R1 is 5 centimeter or 5 meter. Okay, let's suppose R1 is 5 meter and R2 will be 5 meter. So T1 will be equal to 5 divided by, if cos theta is going towards 90, then the theta will getting decreasing. So it means that, now for example, it is 45, cos theta is 45. Now for T2 we say that 5 divided by cos 30. So cos 45 is lesser than cos 30. So if we divide the smaller number by the same number, one is smaller number, one is greater number, so we'll get T1 will be greater, while T2 will have smaller value. So it means that T1 is greater than T2. Okay, for this our correct option is B. So B is our correct option. R1 equals to R2, T1 is greater than T2. Okay, moving towards next question, that is, an object shaped is a hemisphere rest with its flat surface on a table. So this is a hemisphere, not a complete sphere. This point should be noted. This is a hemisphere rest with its flat surface on the table. The object has radius r and density rho. So this is radius r and density rho. The volume of a sphere. So this is the volume of a sphere, not a hemisphere. The volume of a sphere is 4 over 3 pi r cube. Which average pressure does the object exert on the table? So we have to find the pressure. So we know that pressure equals to force over area, but here the weight of the object is a force exerting on the table, so it will be weight over area. Now we know that weight of the object is mass times gravitational acceleration over area. So this will become a circle, and so this will become a circle. It is in a circular shape, so we will say that area of a circle is pi r square. Okay, now for mass we'll write, we know that density equals to mass per unit volume, and we know that mass equals to density times volume. Okay, so here we'll write that density times volume of the sphere, volume of the hemisphere, okay, times g divided by pi r square. Okay, so the pressure will be equal to rho. Volume of the sphere is 4/3 pi r cube, while volume of hemisphere will be equal to total volume divided by 2. So 4/3 whole divided by 2 pi r cube, it will be equal to 2/3 pi r cube. Okay, now we'll get that the volume of hemisphere will be equal to 2/3 pi r cube into g divided by pi r square. So pi and pi will cancel each other, so there is r square, and so one r will be left. So we'll get pressure equals to 2/3 rho r g. So this will be a correct option. So here it is 1/3 rho r square, 1/3. So this is not a correct, this is not a correct. This is 2/3 rho r g. There is no g. So our option D is a correct one. Okay, question number 14. A probe is used to monitor the quality of the water in the sea. So this is a probe, and this is used to monitor the quality of the seawater. Now the probe is suspended by a vertical string. So this is a vertical string which is attached to a sphere. So this is a sphere, and the string is attached to the sphere. The stationary sphere floats in equilibrium on the surface of the sea. So note this point, that the stationary sphere floats in equilibrium on the surface of the sea. So it is floating, it is not sinking, it is floating. Okay, this point must be noted. The sphere has a weight of 5 Newton. So weight of that sphere is 5 Newton. Okay, the probe and string have a combined weight of 2 Newton. So weight of probe plus weight of string is equal to 2 Newton. Okay, now the density of water is equal to 1.03 cross 10 to the power 3 kilogram meter inverse cube. Okay, now the upthrust acting on the probe and the thread is negligible. So the upthrust which is acting on the probe and the string is negligible, but not the upthrust which is acting on the sphere is negligible. One point was that the sphere is floating, and the other point is that the upthrust only which is acting on the string and the probe is negligible, while the upthrust acting on the sphere is not negligible. Okay, what is the volume of the sphere below the surface of sea? So we have to find the volume of sphere below the surface, or you can say that the volume of the sphere submerged in the water. Okay, volume of sphere submerged. So we have to find it. Okay, now I'm going to the first point, that is the sphere floats in equilibrium on the surface of water. Now according to Archimedes' principle, that there are two results. If we submerge an object in the water and the fluid, then there are two results: either the object will float, or the object will sink. So when the object will float, when the buoyant force or the upthrust force acting on the object is equal to the weight of the object. So when the weight of sphere equals to the buoyant force, then the weight of the sphere equals to the buoyant force, then the object will float. Okay, make this point notable that when the weight of the sphere is equal to the buoyant force or the upthrust force, then we say that it is what? The object will float on the surface of water. While or if the weight of the object is greater than the buoyant force, then again the object will float. But if the weight of the object submerged in the water is less than the buoyant force, then the object will sink. Okay, this point was the first one and it must be noted. The second point is, now how will we say that what is the buoyant force? So you can say that the buoyant force is the upthrust force. So upthrust force will be, is the object, is this situation or the conditions is in equilibrium, then we say that the weight of the sphere plus the weight of probe plus weight of string will be equal to the buoyant force or the upthrust force. So buoyant force will be equal to 5 Newton plus 2 Newton, and it is 7 Newton. Okay, now okay, make here up to here, make this point clear that the buoyant force or the upthrust force are same thing, and whenever the object is floating on the surface of water, then it means that these two are equal to one another. Now according to Archimedes principle, how will we calculate the buoyant force? So according to Archimedes principle, the buoyant force is equal to the weight of the disturbed fluid or displaced fluid. Okay, weight of displaced fluid, and it is equal to 7 Newton. Okay, now the weight of displaced fluid will be equal to density of displaced fluid, or you can say that density of fluid multiplied by volume of the displaced fluid multiplied by g. Okay, so this will be equal to 7 Newton. Now what is meant by the density of disturbed fluid or displaced fluid or volume of displaced fluid? So we have to find the volume of the sphere. So the sphere will displace the fluid with the mass that is inside the seawater. So it means that too much water will be displaced. So we will take the volume of, so the volume of the displaced fluid will be equal to the volume of the sphere which is inside the seawater. Okay, so we can write that the volume of displaced fluid is equal to volume of sphere submerged in the water, volume of sphere multiplied by density of fluid. Here fluid is seawater, density of fluid multiplied by g, and it is equal to 7 Newton. Now we'll do the calculation that volume of sphere equals to 7 divided by density is 1.03 cross 10 to the power 3 multiplied by 9.8. Okay, so we'll do the calculation. So first of all, 1.03 multiplied by 9.8, it is equal to 10.094. Okay, so it will be equal to 7 divided by 10.09. So the 10 power plus 3 will be shifted to the numerator and it will be equal to minus 3. Now we'll divide 7 by answer. Now you'll get 0.693. So 0 point, we'll get that 0.693 cross 10 to the power minus 3. Okay, and it will be equal to meter cube. Why? Because it is the unit of volume. Now if we shift the decimal to the one to the right and lift a non-zero digit to the left of the decimal, then we will write that the volume is 6.93 cross 10 to the power. So we'll shifting the decimal to 1 point, so we'll write here minus 4 meter cube. Now this will be the, so this will be the answer. Okay, and option D is the correct one, 6.93. Okay, moving towards next question. What is the center of gravity of an object? So simply here, the definition of center of gravity is asked. Now you know that center of gravity is a point where the whole weight of the object is considered to be act. Okay. So here in option, the geometric center of the object, no. The point at which the weight of the object may be considered to act, yes, this is a correct option. The second, the C, the point on the object about which there is a zero net torque, no. The point where gravity acts on the object, no. There is another definition, like you can say that the point where the acceleration of the body is zero. Okay, the acceleration of the body is zero. Okay, so with this we have solved up to question number 15. So in our next video, in our next class, we'll continue from the question number 16 and onward. Okay.